Hello guys, you are welcome to RE Mathematics and Physics class. In today's video we'll be dealing with elasticity. So what is elasticity, or what is an elastic material? For example, let me say I have a spring like this. So later on I applied a force here and a force here too, and then I expanded this spring to be like this. So I've done something here. I've applied a force and it is making this thing to expand. What if this same spring I reduce it by applying a force like this, making it smaller? So it is smaller like this. So what I've done here is what? Compression. So I compress it. So now there's something we call what? Hooke's law. So Hooke's law is the law that obeys this. It states that what? Provided elastic limit of an elastic material, this is an elastic material, is not exceeded, the extension or what change in length is either it is increasing or decreasing, or what the extension or compression of an elastic material is directly proportional to the force applied to it. That is, the force applied to this thing is directly proportional to the extension E. So this is what we call what? Hooke's law. Hooke's law. So we'll be using this Hooke's law in the calculation of what? Elasticity. So now let me, by removing this constant of proportionality, so what do? We introduce a constant, right, and make this equal to, let's say the constant is k, then we put our e. You see this k here is called what? Elastic constant. Elastic constant k. Now, so how do we do it? Force is measured in Newton. Now, making this elastic constant the subject formula, what do? We divide both sides by what? By the extension. So we then have what? F over what? E. Since this is measured in what? Newton, and this one is measured in what? Meter, and the unit of what? K is what? Newton per meter, or what? Newton per meter, like this. So that's the unit of what? The elastic constant K. So now this, assuming we are having two or more force, so we can say that what? The elastic constant, and we are asked to find what? Maybe this. So we can use this constant using the law of connectivity when we are having two or more forces and two or more extensions. So we are asked to find one extension or the other side. So what are we going to do? Let's say we have what? F1 over what? Let's say F1 over what? Extension 1 is equal to what? F2 over what? Extension 2. So, and it will still be equal to F3 over what? Extension 3, like that. So let's stop here. So maybe we are given two or more force. Maybe we are given F1, E1, E2, and we are asked to find the what? Dot force. So we can simply use this formula, or we do what? We just first find the constant, elastic constant first, and then we apply it into this back to get our force. So we can use the two methods. Now that's about Hooke's law. Now we'll be dealing with the work done in spring or elastic material. So the work done in spring or elastic material, let's say the work done W is equal to what? The average force multiplied by what? The extension E, right? So now, what is the average force? Let's say we have F1 plus what? F2, then over 2, right? Multiplied by this E. So when we add this together, F1 plus F2, we still get one force, so which will be equals what? F over what? 2 multiplied by what? E. So we can say that work done, since work done is equal to what? Energy, and so we can say that what? Work done or energy in what? Spring in spring is now equal to what? 1 over 2 what? Fe, right? So that's one formula for work done. But from this place, from Hooke's law, we know that our force is equal to what? Ke. So inserting this force into this F, we have what? W equals what? 1 over 2, then what? Ke multiplied by what? E. So this will actually give us 1 over 2 E times E, that's E square, Ke square. This is another formula. That is work done is equal to what? 1 over 2 Ke square. So that's another formula for what? Work done. Now, why not making E the subject formula from this place? Okay, let's try it. Let's see what we get. Since our force is equal to what? Ke. So our E will be equal to what? Dividing both sides by what? K. F over what? K. Then inserting this F over K into this place, what do we have? We have what? Our work done will now be equal to 1 over 2 multiplied by what? Our force. Then multiplied by what? Our E, which is what? Force over what? E. Then what do we have? We have W, which is our work, is now equal to 1 over 2 first times what? F square over what? Let's take this together like this. Over what? This K. So okay, so now we have three formula for work done here, which is what? 1 over 2 F square over K, or F square over 2K. We also have what? 1 over 2K square, and we have what? 1 over 2 Fe. So these three formula we can use it in work done in extension or spring. Now we have what we call Young modulus. So Young modulus, let's represent it as this alphabet, like gamma is equal to tensile stress, which is the same thing as stress. Let's say stress all over the strength. Tensile stress. What is tensile stress, or what is stress itself? Stress is the ratio of the force to area. That's what stress is, what? Force over what? Area. The unit is what? Since this Newton and this what? Meter square. Area is meter square. So the unit is what? Newton per meter square. Right? Now, our strain is what? The original length. No, the extension over what? The original length. Where our extension can be what? The final length minus what? The initial length, or the original length over what? The original length. So that's our extension. Now let's use this, and this can be what? Changing what? Length over what? Length, like this. Now our this thing can also be like force over what? Area. Let's use for circle. What's the area of a circle? By r square. So sometimes you'll be given diameter or radius, so you just have to use this force over what? By r square. Now since we know our stress is force over area, and our strain is what? E over what? A mu. Now let's insert it here. We have our Young modulus to be what? That's what? Force over what? Area. Then E over what? L naught. So our Young modulus will now be what? Force divided by area divided by what? Extension over what? L. Now our Young modulus, by changing this division to multiplication and changing this to what? To the reciprocal. Now what? Force over area multiplied by what? L over what? E. Hence our Young modulus will now be what? Fl over what? Let's say this original length over what? A. So this is the formula for what? Young modulus. So now let's take example. We also have bulk modulus, shared modulus. So very soon I'll create a video on bulk modulus and shared modulus. But now let's first solve this question involving what? The elastic constant, the force, the extension, the work done in spring, and we solve a question on Young modulus. That's all for today. But before that, let's see something. What will be the unit of Young modulus? The unit will still be what? Newton per meter square, or what? Pascal. So, and the unit of stress will also be what? Newton per meter square, or what? Pascal, because this is force over area, and pressure is also what? Force over area. So our stress, the formula for this stress, we can also use it for pressure. So now from this Young modulus, since this is our force, this is our area, we have Newton, we have meter square. But this is measured in what? Meter, and this is also measured in meter. So meter will cancel meter, we have what? Newton over what? Meter square. Then we have our Young modulus to be what? Newton per meter square, which is what? Pascal. So here is the question. The force of what? 4 Newton is stretches an elastic material by what? 50 mm. What additional force will stretch the material by 55 mm? So we are looking for what? Additional force. So the additional force that will what? Stretch this thing to what? 55 mm will be the what? Additional extension. So the additional extension will make it this. So let's assume this is the body. Let's say it is the spring. Let's say the force applied to it is 4 Newton, right? So, and let's say it extends it by what? It stretches it by what? 50 mm. Then later, it's this is what? 4 Newton. It stretches it for, let me say, for what? 55 mm, right? And they say for 55 mm, you'll notice something that what? For this, let's say this is the force we are looking for, that we don't know. The total will be what? 55 mm, right? But there's one thing. From this place to this way, we have this to go 50 mm already. So what is the additional extension? So it is the additional extension we will use to calculate what? The force. So what is the additional extension? This is the final extension, which is what? So our E will now be equal to what? 55 minus what? The 50. So which will now be equal to 5 mm. And this place will now be what? 5 mm. So now what are we going to do now? Since we know that what? Our force is equal to what? KE. So we can use the law of connectivity, or we can first insert this 4 Newton here, insert the first 50 mm here, then we get the constant K. So that constant K, when we are to find the next this thing, we multiply the constant K by what? The extension, which is 5. So to get our second force, either we do it like that or what? We use the law of connectivity that what? F1 over what? F2 over E2 E1 equals what? F2 over what? E2. Hence, what will be our F1? Let's say 4 Newton over what? 50 millimeter equals what? Our F2, but I don't know, over what? Over what? Extension is what? 5. Extend by what? 5 millimeter. So then we cross multiply, right? So now 5 times what? 4 over what? 50, which is what? 20 over what? 50. That's what? 0.2 Newton. That's 0.2 Newton. So that's the additional force. Now this is example 2. So what we are going to do now is we are asked to a wire of diameter 2.8 millimeter support a weight of what? W. If the tensile stress in the tube is this, the value of W is, we are asked to find the weight. Fine. We know solution. Weight is the same thing as what? Our force, right? Okay, now we will now find the formula that relates, since we are giving stress. So stress to what? With stress is equal to what? Force over area. But we are not giving area, but we are giving, so our force here will not be equal to what? Area multiplied by what? Stress given, right? But we are not giving area, but we are giving something diameter, and we know our area can be what? By r square. Since we are not giving r, first we are giving diameter, and you know that when we have a circle like this is the diameter, this is the center. So from this point to this place is what? Radius. This is also radius. So diameter is what? 2 radius. Hence radius will not be equal to what? Diameter over 2. So now let's try to do that. Let's try to calculate our radius from this place. Since we know that this is in millimeter, so we just say that 2.8 times 10 raised to the power minus 3, it will now be in meter like this, over 2. Then we will now get our radius. So our radius will now be what? 2.8 times 10 raised to the power minus 3 divided by 2. That's what? 1.4 times 10 raised to the power minus 3. So this will be our radius. But we've not gotten our area. Our area will not be equal to what? 1.4 times 10 raised to the power minus 3 multiplied by what? Pi, which is 22 over 7. So multiplying the answer by what? Pi, we have something. We have our area to be what? 4.39 times 10 raised to the power minus 3. Now that's our area. No, there is a mistake here. We know that it is pi r square. So then we have to square this. It will not be what? It will be what? 1.4 times 10 raised to the power minus 3 plus by all square. We now have what? 1.96 times 10 raised to the power minus 6 pi. So our area will now be equal to what? Our area is now equals to 6.157 times 10 raised to the power minus 6. Let's say this is our area. 6.157 times 10 raised to the power minus 6. Now we are given stress and we've gotten our area now. So to get our force will be very easy. So what do we do? Since our force is what? Area, which is 6.15 times 10 raised to the power minus 6 is with this, multiplied by the stress given, this is stress, 2 times 10 raised to the power 7. So our force will now be equals to times 2 times 10 raised to the power 10 raised to the power 7. So our force will now be equals to 123.15 Newton. Let's say 123. Now these are force. 1 2 3 Newton. Let's say it is 1 2 3 Newton. Now we've done the first question, and our force is equal to our what? Weight. Hence this force is the same thing as weight, which is equal to this. So now if the wire in the question above has the Young modulus of this and unstretched length of this, what's the extension? We are asked to look for the extension now. We know something that what our Young's modulus is equal to what? Force length over what? A what? This. So by making this is the survey formula, we now have E will now because what? Fl over what? A then Young modulus, right? Now this is what we are looking for. We know our F, we know our A, we have our Young modulus here, and we are given unstretched length, that was the original length, that is when it is not stretched. So but it is given in centimeter. So what do? We see that what 100 centimeter to meter is not what 100 times what 10 is power minus 2, which is what 100 times what 1 over what 100. So which will actually give us what 1 meter. So our length here will now make us what 1 meter. So what do now? We insert the value. So our extension now will now be equal to what? What's our force? 123 multiplied by 1 over what? Our area is what? 6.157 times what? 10 is power minus 6 multiplied by our Young modulus, which is this 2 times 10 is power what? 10. Then when we multiply this, we have something like 123 over what? 123,140, which is going to give us what? 0.9 something. It is giving me what? 9 times 10 is power minus 4. So hence this is my extension. But we are not done with the question. I like this question. So hence find the work done in the wire. So we simply have formula for work done. So since we have our F and we have our E, we can use 1 over 2 F multiplied by E, which is the original formula. So that is what average force multiplied by the extension. So what is the force? That's 123 multiplied by what? 9.9 times 10 is power minus 4. And then our work done, which is our energy in spring, will be what? That's multiplied by 123, which is what? 0.122 Newton. Work done is measured in what? Is it Newton? Our first time is distance. That's what? Newton meter. It's or joule. So this is the final answer. So now we've gained a lot from this video. I hope you enjoyed the class. So please click on the subscribe button, share my videos, comment, like and subscribe. Thanks for watching. Please subscribe, like and also comment.